All right, I want to look at another problem, and this one will have some similarities but also some differences. I want to find the horizontal asymptotes of f of x equals the square root of 2x squared plus 1 all over 3x minus 5. Now we're going to do what we did similarly in the last problem. We're going to divide the numerator and denominator by the highest power of x in the denominator. In this case, that's just x. And then we're going to use some of these limit laws to rearrange things here. So first, let's take a look at the limit as x approaches infinity of this function, the square root of 2x squared plus 1 over 3x minus 5. We're also going to have to look at the limit as x approaches negative infinity, because we might have a different horizontal asymptote to the left, but let's just start with the right. Now we know we want to divide the top and bottom of this by x. The bottom is a little bit easier. If we divide that by x, that's going to give us 3 minus 5 over x. In the numerator, if we divide this by x, that's the same as dividing the radicand by x squared, because x is the same as the square root of x squared when we've got x approaching infinity. We know x is positive in this situation. So that ends up causing us to divide the inside of the radical by x squared. So that's going to be 2 plus 1 over x squared inside that radical. Now, we can take the limit of a quotient and rewrite it as the quotient of the limits. So that is going to end up being the limit in the numerator as x approaches infinity of the square root of 2 plus 1 over x squared all over the limit in the denominator as x approaches infinity of 3 minus 5 over x. Now we know that we can bring the limit inside that radical. That is another one of the limit laws that we have. And we also can then split up the limit of the sum into the sum of the limits. We can take the limit of each of these terms individually. Same with the terms in the denominator. So let's just go through and do all of that in one step now, so we don't have to write out a million steps. This is the square root of the limit as x approaches infinity of 2 plus the limit as x approaches infinity of 1 over x squared. And then in the denominator, we have the limit as x approaches infinity of 3 minus the limit as x approaches infinity of 5 over x. And then we can evaluate these. The limits that have the x's in the denominators, those are going to equal 0. And then the limits of the constant terms are going to equal those constants. So in the numerator, we're going to have the square root of 2 plus 0. And then in the denominator, that's going to be 3 minus 0. And this is going to end up being root 2 over 3. So because the limit of our function as x approaches infinity is root 2 over 3, that means we're going to have one horizontal asymptote at y equals root 2 over 3. That is one of them. But we also need to look at the limit as x approaches negative infinity of this function to see if perhaps we end up with a different limit in that direction. Now, a lot of what we're going to do here is going to be the same, but some of it is going to end up being a little bit different. And in particular, the place where something's going to be different is actually this first step when we divide the numerator by x. And I want to do this off to the side here. If we take the square root of 2x squared plus 1, and we divide that by x. Now, in the last problem we did, or in the last limit, we said that x was the same as the square root of x squared. And that was true in this problem because x was approaching infinity, so x was positive. But in this problem, since x is approaching negative infinity, the x values we're looking at are negative. So this ends up being negative, but if we leave it like this, that is a positive number because the square root symbol by itself automatically gives us the positive square root. So to recognize that the denominator is a negative number, we need to put a negative outside of there. And then we can put the negative out front and combine both of these under the radical, 2x squared plus 1 over x squared. And then when we go ahead and do the division, 2x squared divided by x squared is 2, and then plus 1 over x squared is 1 over x squared. And we end up with exactly what we had before, except a negative sign out front. And so this is going to be equal to the limit as x approaches infinity of the negative square root of 2 plus 1 over x squared all over 3 minus 5 over x. So the difference between these two problems is this one has a negative out front. Now we can still do all of the same properties that we did over here. We can split the limit up so that we've got one in the numerator and one in the denominator. We can even bring that limit inside the radical. And we can split up these terms here. Everything is going to be identical. All of the calculations are identical, except we're going to have a negative out front of the square root. So we're going to have a negative here. And when we pull the limit inside, the negative is going to stay on the outside. And the negative is going to stay on the outside there. And it's going to stay on the outside there. And we're going to end up with those same steps getting the negative square root of 2 over 3 instead of the positive square root of 2 over 3. And so in this case, that's going to give us a horizontal asymptote of y equals negative root 2 over 3. So we have two horizontal asymptotes in this situation. Let me show you a quick graph of what this function looks like so you can see exactly what's going on. Here we've got a computer-generated graph of this function, and the limit of the function as x approaches positive infinity, you can see is a positive number, happens to be root 2 over 3, which is around 1/2, not exactly, a little less than 1/2, but there you go. And then on the left-hand side, the behavior is different. We've got a different horizontal asymptote. This one is a negative number because it's below the x-axis. And in fact, that is our negative root 2 over 3. So this is an instance where we have different limits as x approaches positive infinity and as x approaches negative infinity. So we're going to have different asymptotes on each side of the function.